Welcome to queenon7.com. Please share and like my videos. Today we're going to look at the electrolysis. This video is actually for the GCSE students only. Electrolysis means you actually breaking or splitting a compound into its component by using electricity. It is actually came from the two parts. Electro means electricity, and then lysis means, it's a Latin word which means splitting. Now electrolysis is going to give you, for example, if you have potassium bromide, you will break potassium bromide using electricity. In electrolysis chapter, before we start the electrolysis of aluminium oxide and sodium chloride, we need to look at the basics of electrolysis. You need to learn two things. One, what is meant by aqueous solution, and what is meant by molten, because that confuses you a lot when you do the electrolysis. If you look at the first bit, which is aqueous solution, the word, it says aqueous. You sometimes see the word is written as AQ as a state symbol under those elements or atoms in the equation. So AQ means it's actually in the water. So a compound, when it is dissolved in water plus water, that is called an aqueous solution. Molten means it's a melted form, like you have salt at home which you eat, put on fish and chips. You dissolve that salt in the water, that will make a solution, and that is called aqueous solution. If you take that salt onto a spoon and you melt it, that will be actually called as molten, because there is no water, it's just the salt which is melted in the on its own. Now, for example, if you take an example of potassium bromide, KBr, if I am trying to dissolve it into water, I will actually, because it's an ionic compound, I will actually break it. Now, because you have two different compounds, they will produce two positive ions and two negative ions. From KBr, I'm just going to give you a shortcut to remember anything, regardless of molten or aqueous. When you see them in chemistry, it's a shortcut to remember, not entirely true, but it is for something to remember at GCSE level. The first bit, all of them, mostly they are actually metals, and metals always form positive ions. So all of them, they will produce K positive, Na positive, and Al3 positive ions. And you can have calcium as well if you have KCa2 plus ion. So the first bit of any compound, they always make a positive ion. Now this plus 2 plus 1 plus 3 is actually based on the position in the periodic table. Because potassium and sodium belongs to the first group, aluminium belongs to the third group, they will have 1 and 3 electrons in the outer shell. They can have actually maximum of 8 electrons, so they will lose those outer electron to become stable. Either they have to gain, for potassium it has to gain another 7 electrons to make it 8, so it's better to lose the last electron and have the inner complete shell. Same goes for aluminium. It has 3 electrons, it requires 5 more. The easiest way for the aluminium to become stable is to lose those 3 electrons and become stable. So that's not the part of what we are going to learn, but it's just information you need to remember, that how they actually converted into a positive and negative ion. Now, if I would like to mention that how many ions I'm going to make in the aqueous solution, you need to remember you will always have, in the aqueous solution, you will always have 2 positive ions and 2 negative ions. That's what you need to remember. So for KBr, you will have the first bit is positive, as I told you, it will be K positive, and then you have Br negative. Because it's an aqueous solution, so the water always produce H positive ion and OH negative ion. So you will have 2 positive and 2 negative ions in the aqueous solution. But if it is a molten form like KBr, then it will be actually only K positive ion and Br negative ion. If you want to put plus, doesn't matter. Once you melt it in the molten form, it will only have these 2 ions. In the electrolysis, you use electricity. I'm going to give you a basic understanding of these ions. So if this is the container you are using to do the electrolysis, you need to have 2 electrodes or two sides where these ions can go and exchange the electrons. So you will have 2 electrodes there, and those 2 electrodes are connected with the battery. The one which is connected with the negative terminal of the battery will be known as negative electrode, and the one which is connected with the positive will be known as the positive electrode. In chemistry, the positive electrode is called anode. So anode means it's a positive terminal. The negative will be known as cathode. Cathode means a negative electrode. Both are actually either made by platinum if you're using, but mostly for normal electrolysis we use carbon. So both are made by carbon, and they only made negative and positive because they are connected with the battery. Now we are going to put the aqueous solution first. We can do that later on in my videos. You can look at it. If I put the aqueous solution there, you will have 4 ions. If I put only molten, then these 2 will be appeared here. I'm not going to go into the details today. I'm going to explain that in the next video, where you can actually look at how the aqueous solution have 4 ions and how molten will have 2. And let's just say you have potassium and bromide ion, molten form. 2 ions are there. Now, because they are charged species, negative and positive, a negative ion will go to the positive electrode, and the positive ion will go to the negative electrode, which is a cathode. So here you can say the potassium will go towards cathode, because potassium is positive and cathode is negative. Opposite charges attract each other. And then you have bromide ion, sorry, it will go towards the anode, which is the positive terminal. And what will happen there when they're going to actually reach these 2 electrodes? What will happen there? That is called half equation. You're going to write what will happen to these 2 individual ions at each electrode. Once you have decided which one is going where, then you will talk about what will happen in terms of electrons. Now in chemistry, any species which carry positive charge, that means they have a lack of electrons, so they will gain the electron and convert into a normal atom. And the electrolysis whole process is actually explaining that how you are going to convert these charged species into the normal atoms. So the main focus is how you're going to convert K into K plus ion into K, and how you're going to convert Br negative ion into Br, a normal atom. So potassium K positive ion, which will go towards the negative electrode. Potassium K plus means it has lack of electrons. Because it has lack of electrons, so it will actually gain the electron. Because it is negative, so negative electrode can provide those electrons. So electrons are actually moving in the circuit and coming here, and that will deliver to the potassium. So potassium has +1 charge. It will gain only 1 electron, and it will convert, because it is aqueous, it will be converted to potassium atom. Then you will have bromide ion, which has gone to the anode. Bromide means it has an extra electron. Because it has an extra electron, that's why it is carrying a negative charge, because electron has a negative charge, proton positive and neutron no charge. Now bromine has to get rid of that extra electron. It's a burden on the shoulder of bromine. So bromine will lose the electron. So when it is lose that electron, it should be on the other side of the arrow. Like here, potassium has gained one electron, so they both join together to make potassium. Here, the bromide ion will be converted into Br and plus electron there. Now bromine halogens or nitrogen, hydrogen, they cannot stay as an individual atom like this. So they are always stays as a diatomic molecule. So it will actually converted once the bromine is going to go there. Two bromines at the anode will combine together to make a bromine Br2 molecule. So bromine, to balance this, two bromide ion will go there to make bromine Br2 and will lose 2 electrons, because each bromide lose 1 electron, 2 bromide will lose 2 electrons. So just remember, whenever you see fluoride will be converted into fluorine, bromide into bromine, chloride will be converted into Cl2, hydrogen will be converted into H2, and then you have nitrogen will be converted into N2. So any of these, whenever you see them, remember they will be converted into the diatomic molecule, and then you balance them and you will balance the electrons accordingly. Thank you very much. I will upload some more videos about the electrolysis of aqueous solution of sodium chloride, and also the molten electrolysis of the aluminum oxide. Thank you very much. Bye bye.